The next block we can study is P block. This P block has 6 groups starting from 13th to 18th. And let us start with this. 13th is boron, carbon, nitrogen. Sorry, I have to go downward. So it will be boron, aluminium, gallium, indium, and thallium. 14th group includes carbon, silicon, germanium, tin, and lead. 15th include nitrogen, phosphorus, arsenic, antimony, and bismuth. Bi is bismuth. 16th include oxygen, sulfur, selenium, tellurium, and polonium. 17th includes fluorine, chlorine, bromine, iodine, and AT-astatin. And then 18th include helium, which is actually is into your first period, so that's not here. Then we have neon, argon, krypton, xenon, and radon. So this is in general your whole P block, which is actually having elements starting from the second period and then moving up to the 6th period. 7th period is left as such because elements are yet to be discovered and they are to be placed here, or whatever the elements we are knowing about that this 7th period, they are actually all artificial ones. So we study all the elements till the 6th period. This is the 6th and the last period we study in the P block. So this is what the P block we have. It is the most complex block of the periodic table because it is the only block in which we have metals, non-metals, and metalloids together existing. Also, we will find great variation in their properties of the elements when we are moving from top to bottom in a group, because the topmost elements are non-metals or maybe showing the properties of non-metals, middle one will be showing properties of metalloids, and the later ones are showing the properties of metals. So a very diverse, very distinctive properties we notice in the elements of the P block, and very we can clearly observe how their behavior are changing from top to bottom. So that's very important block because that's having all our non-metals and metalloids. So this is what is your P block is. Now what is most important to note is their general electronic configuration. Now general electronic configuration of P block is NS2 NP1 to 6, because the P suborbit will be having 1, 2, 3, 4, 5, and 6. Since P suborbit is subsequently filled, the electrons in that can be from 1 to 6. So the general configuration is NS2 NP1 to 6. Now let us see the configurations of these groups individually. 13th wall will be having NS2 NP1, it will be having NS2 NP2, it will be having NS2 NP3, it will be having NS2 NP4, this will be having NS2 NP5, and this has NS2 NP6. So these are the general individual classification configurations of these 6 groups, and with the help of this what we can find out is the number of valence electrons these are having. See here, the number of valence electrons are 3, so that's why they all are belonging to the 13th group, because as I have told you, the valence electrons is equal to group number minus 10. Now these elements are having how many valence electrons? 2 and 2, 4. That's why they are in the 4th group, 14th group. Now number of valence electrons are 5, so they are in the 15th group. Valence electron 6, 16th group. 7 valence electrons, 17th group. And this is how we have noble gases whose all valence suborbits are completely filled. That is why they are found to be very, very stable. So these are their general configurations. We can do one more thing. We generally name these groups on the basis of the elements of the first element of their individual group. So that's why group 13 elements are also called boron family, because boron is their representative. 14th group elements are called carbon family. The reason is carbon is their representative. Group 15 are called nitrogen family. They are also called in general nicogens. Then group 16 elements are called oxygen family. They are also called chalcogens. And group 17 elements are called more commonly halogens, salt forming. The last group elements are called noble gases or inert gases, because they doesn't react with any other element and they always exist in their atomic states. They doesn't even combine with one another to form molecules. That's why they are called noble gases or inert gases.